A flame photometer is an instrument that you'll use to trace metals. And the trace metals we have, and you can analyze. Using this machine is sodium, potassium, calcium, barium, and lithium. Only 5. Okay. It's a flame photometer. You can already see the flame in there. This section of the flame photometer, this is called a nebulizer. Nebulizer, the capillary tube. You get the capillary tube, you dip that into the sample to suck the sample. The sample are taken in with the aid of the pump. The pump causes suction in the nebulizer. It sucks in the sample from the sample bottle. When it goes in the air sprays that into the flame. And you have here, these are the filters, 5 filters. Filters for sodium, potassium, calcium, barium, and lithium. These filters, they only, when you select for one, you are only detecting any reading that appears on the screen will only give you the reading for what you have chosen. Using this knob. Now it's facing sodium, Na, and potassium, calcium, barium, and lithium. Any other chemical is filtered. It's only sodium that will give the reading. Analog reading there. Okay. I think that's all I could say. This message will tell you exactly how precise you have prepared the sample. And by the readings up there on the board, I can already know if you have prepared it well or not. The precise reading, if you're using measuring cylinder, it should be very exact. If you're using weighing balance, analytical balance, it should be exact. And then you bring your sample in solution to run it through this machine. It will give you exactly how much you have done to your sample. So that's how precise this machine is. Okay, by understanding this machine, after going through this one, it will be easy for you to do AAS. But the difference is, AAS, they have lamps. If you want mercury, you put in mercury lamp, you put in your sample, and it gives you the reading. But first and first, you understand this one, then this will be a stepping stone to advance into AAS, Atomic Absorption Spectroscopy. Okay, sodium, we have done all the sodiums. We can do one calcium for that. So, sample in the blank, your nebulizer tube in the blank, a capillary tube. Then when you dip that into the first thing you would do is you select the filter to calcium. Okay, we are there now. Now you take the capillary tube out from the distilled water into the sample. But it's not good all to use the beakers. Beakers are not good. The right glass was the volumetric flask, the small ones. So it's easy to shake. You can use the beaker to shake.
So what happens here? It sucks the.
Yeah. Okay. You if you can see that the sample traveling in. All right. Calibration for this, you will have to, like when the people were trying with people, what I did, I had to hook up the connector just here, then I switched on the pump just to help the nebulizer to suck in the samples. It goes in and sprays. Okay, calibration, you will have to use a distilled water. Any blank, here, I just want to explain what blank is. If you are using something, a medium that you use to make up your sample, that medium is your blank. Blank is not always a distilled water, it's not always any tap water. So you don't get mixed up. Blank is anything that you use to make your sample. And then that medium you use to make your sample, when you bring it here, you will have to use that as your blank. Dip this one into the blank, then you zero this, and it will give you all zero. And when you're supposed, if you're asked to determine bearing, then you select the filter. You dip the capillary, the tube here, into the sample. It sucks in, and any reading that it gives will not be for the blank. It's for the sample. So the blank is anything that you use to make up your solution. And sometimes they get mixed in the labs. People think blank is only for the distilled water or tap water. It's never blank. Blank is any medium you use to make up your sample. Like you don't have water and you use Coca-Cola to add your sample in, and you make up your sample and to determine for calcium. Then you can use that as your blank. You put in Coca-Cola, then you zero your reading. And then when you put in your sample in, it gives you what you expect. A flame photometer. What else? Yes. And if I look at the sample on the board now, the readings, I would know exactly how you have prepared your sample, where you have gone wrong. And never say, oh, it should be okay. Analytical balance, weigh exact amount. The measurement, meniscus reading, it should be exact. Concentration, when you get them together, the concentration, this machine will tell exactly how much of what you have prepared. So be precise in your measurements. Because you'll be out there in the field all the time. Sample collection, solution making, all these things should be precise. Then you won't sweat out when you bring in samples to the lab. You'll be happy and you just go through. Yeah, okay. Then when you bring your samples blank, I'll just go through that again. Blank is not always water. It's any medium that you use to make up your solution. Blank is not only water. It's anything that you use. If you go up to Mount William and you collect a sample, you have no water there. What would you do if you have a can of Coke there? You use your can of Coke. You make up your sample. Then you bring it to the lab. You use the can of Coke to use that as a blank. And the reading you get, that anything from the can of Coke will not be given. It's only the sample. So blank is It's never the water only. It's any medium that you use to make up sample. Interesting. You're learning something.
Like with organic solvents.
Yes.
Extraction. So can the solvents, organic solvents, be used as blanks?
Yes, you can do that. You can do that. You can use solvents as blanks too. The solvents will not be direct. You make solvent into a solution before having that mixed with the sample. So that solution will have to be taken to the lab as blank. Yes.
So the blank is good for that. It's only for the solution, so that the solution will get the
Blank is for the analyzed solution you'll be using. Like this one, you use distilled water, so we are using blank as distilled water. How do you use an SP bottle for that SP? I can use an SP bottle. I'm just saying that. I'm not saying you do that.
One is I can smell this.
Yes.
So that's pushing it.
Uh-huh.
Number two is I realized as soon as you remove the capillary tip from the filter, flame decrease.
Right.
So it's pushing it.
Not. It will decrease when. It will decrease when you remove this out.
Yeah.
And when you
Remove this one from the
nebulizer.
nebulizer.
Yeah.
I noticed that the flame decrease.
It's because some of the air from here that goes in because I was just in the way. I pushed it right in, it was in the way for the air to increase the flame. You need oxygen to aid the flame, so it was in the way for the air from the pump. That's why it did that. Any sample from here is carried in with the aid of the aspirator. It sprays the samples into the flame. That's why it's called That's why it's called the flame photometer. But every time for sodium, it will go yellow, the flame. And if you analyze for potassium, the color will change. So make sure you also see the color changes. Calcium, barium, the color changes. Generally, you want to see it in the slope. Yeah, that's it. Give a good slope. Yeah, 0.4 different.
0.04.
0.04 difference there.
0.0334.
Yeah.
It's between 0.03 and
3 and 4. But if you want to get everything 0.04, be careful with the measurements.
yeah. These are standards that was prepared.
Yeah.
So, this is based on literature, so we
Yeah.
expect very similar. For the purpose of the curve,